All right, FRQ number 4. This is symbolic manipulation. As I mentioned earlier, there is no calculator permitted on this part. Okay, so you need to be able to do all the work on these without the use of a calculator. I highly recommend that when you do this one especially, do not get a calculator out. You need to be practicing it without a calculator. You need to be able to do it all by hand. Now, there will always be 3 parts that focuses on content from units 2 and 3. And will never be in real-world context. You'll be asked to work with several functions: exponential, logarithmic, trig, and or inverse trig. 2 parts of the questions, part A or B and part C, will require you to solve equations using given functions. The 3rd part, either A or B, will require you to rewrite given function expressions in equivalent form. That's the symbolic manipulation that they're talking about. When we rewrite given functions, that's going to require us to know our properties, log and exponential, and our trig identities. You will need to know those. For this question, overall, you'll be expected to determine exact values of expressions. Use algebraic methods and rules for exponents and logs to combine terms, and show the work that leads to your answers in each part of the question. So let's look at our summary points here. Question, stem, and function type. This is the most traditional of the 4 FRQs. This is the one where there's no context, there's no like leading paragraph, like, oh, there's this windmill doing these certain things. It's just literally you're given equations and asked to solve or asked to manipulate. And the functions will be from units 2 and 3. So you could have exponentials, and you could have lots of different bases involved. It could be base E, it could be base 2, it could be base 9. Logarithmic functions, again, different bases could be involved. Trigonometric and inverse trig. Question parts progress in difficulty, meaning part A is supposed to be the easiest and part C the hardest. Okay, that's the way that they've designed it. Note the question directions. There will always be a box of directions that we'll see on the next page, and that box of directions will always be included with FRQ number 4. It will always be there. So let's go ahead and look at the parts. Both part A and part B are kind of the same way. Be 2 points. We'll always have 2 parts, I and II, and will require you to either solve or rewrite equations. Language will give specific directions and will require uses of properties, definitions, identities, and algebra. You will need to have those properties and identities. You'll need to have them in your brain for the exam, whether you're doing the full AP exam or my mini exam. Part B is structured the same way. Part 3 will typically always be the most difficult part of the question and may require you to know general solution expressions for trig. When we say general solutions, that's like our plus 2 pi n, right? We'll always use input and output language. All right, let's go ahead and turn the page and look at our example FRQ that we have here. So up there at the top, we have this box of directions. As I mentioned, we will always have these same directions on every single FRQ. So unless otherwise specified, bullet point number 1, the domain of a function f is assumed to be the set of all real numbers, for which f is a real number, and angle measures will always be in radians. But we already know that. Bullet point 2, solutions to equations must be in real numbers. So they do not want any imaginary answers here. Determine the exact value of any expression that can be obtained without a calculator. For example, log base 2 of 8, cosine of pi over 2, and sine inverse of 1 can all be evaluated without a calculator. So let's talk about these, starting with our log base 2 of 8. So how can we do that without a calculator? Well, the idea for this one is to write this as log base 2, and then 8 we're going to rewrite as 2 to some power. So I get that matching base. What is 8 as 2 to a power? What power? 3, right? So that would be 2 to the third. Well, what happens when I have matching bases like that? They cancel, and what are we left with? Just the 3. So log base 2 of 8 is equal to 3, and you would be expected to simplify that if possible. Now, if you got to something, we'll see this today, like a natural log of 2, we can't simplify that, but we could simplify something like natural log of e squared. What would that be equal to? Natural log of e squared. What base is the natural log? So then I have matching bases. What happens? And we're left with 2. So natural log of e squared is just 2. So you could evaluate that, and you would be expected to. But again, something like natural log of 2, which is not a base of e, you couldn't. Okay? Cosine of pi over 2. This one you just get your answer from the unit circle. What is cosine at pi over 2? Up at 90 degrees would be, I heard somebody say it, at pi over 2. What is cosine? So what is the coordinate pair at pi over 2? Up at 90 degrees. What's the coordinate pair, guys? Which one is cosine? The 0. So sine of pi over 2 is 1. Right. Okay, over here, sine inverse of 1. This one, remember, when we're dealing with sine inverse, that is the first in 2 quadrants right here. We don't use quadrants 2 or 3. First and fourth quadrants, I think I meant to say. So where is sine equal to positive 1? At what angle? Think about that. At 0, what's our coordinate pair at 0? 0 radians. 1, 0. And we already set up at pi over 2. What's our coordinate pair? Which one is sine equal to 1? Where is sine equal to 1? Which one is sine? The x or the y? So where is y equal to 1? So our answer is pi over 2. And you would be expected to give that. Okay, so that's bullet point number 2. Bullet point number 3. Unless specified, combine terms algebraically using algebraic methods and rules for exponents and logs where applicable. For example, we would not leave it as 2x plus 3x. What would that be? You would be expected to combine it. And then like this one, 5 squared times 5 cubed. What would that be? 5 to the power of what? Not 6. 5. We add our powers. So an exponential property we want to remember, for multiplying the bases, our powers get added. What about this one right here? X to the 5th over x squared. What would that become? X what? To the 3rd, right? Simplify it. Think about this one over here. Natural log of 3 plus natural log of 5. What would that become? It's a log property. Not a 2. We have adding here between 2 logarithms. How do we combine it into a single logarithm? 15 with multiplication. So that would actually be natural log of 3 times 5, or natural log of 15. So you need to know your log properties as well as exponent properties. Correct, yes. So if it was natural log of 3, let's write that above it. If it was natural log of 3 minus natural log of 5, then that would be natural log of 3 divided by 5. Yeah, so subtraction becomes division, adding becomes multiplication. All right, for each part of the question, show the work that leads to your answers. I've mentioned that a lot. You need to show your work. Do not just give answers. Okay, let's go ahead and jump in to part A. We are given two functions, g and h. Part I, rewrite g as a single logarithm. So single logarithm without any negative exponents. That's going to be important right here. No negative exponents in any part of the expression. Your result should be in the form of natural log and then whatever expression you have inside. So let's go ahead and do it. Starting with g of x. So g of x is equal to 3 natural log of x minus 1/2 natural log of x. We are condensing. What's our first thing we do, guys, when we condense? Do you remember? How are we going to get exponents there? The numbers in the front, where do they go? The back. Now, they said they want no negative exponents, so am I going to do negative 1/2? No, I'm going to bring just the 1/2 and leave the minus where it is. All right, I bring it up. That becomes natural log of x cubed minus natural log of x to the 1/2. Now we just said this, but what happens when we have subtraction? How do we condense it? Division. So I have one single logarithm, and what do I have inside? What over what? Over x to the 1/2. Now, I have to be very careful in what we have here. It says our result should be in the form natural log and an expression. Do we have that? Natural log and then an expression inside. Yes, but let's go back to our directions. What did it say right here that we have to do? We have to simplify if possible. Can I simplify those? Most definitely. How would I simplify that? I heard somebody say it, but what would we do? What do I do with the 3 and the 1/2? Subtract them. So it's natural log. I would have x cubed minus 1/2. Well, how would I subtract those? What do I need? No decimals. Don't use a decimal. And no calculator because it's non-calc. Yeah, that thing, right? Yeah. How do we add or subtract fractions, guys? Common denominator. So yes, I put a 1 underneath. What is going to be my common denominator? So that would be x to the what? Six over 2 minus 1 over 2. I would never give a mixed number, Adon. Don't give 2.5. They don't like those. They might take 2.5, but I would be careful with that. All right, so what do we have? Natural log of 5/2 is my power. And I've done it. I have a single logarithm. There are no negative exponents. I have simplified like they said I need to in the directions. I think they would accept natural log of x to the 2.5 because that is also equivalent. I'd be careful with like something like 5/3. That would be a repeating decimal. That one you would definitely want as a fraction. All right. Any questions on part I? All right, part II. Let's see. We have h of x. H of x equal to sine squared x minus 1 over cosine. They say rewrite h as an expression in which cosine appears once and no other trig functions are involved. So our answer needs to be just cosine, or maybe cosine squared, okay, but just appearing once. So this is our identities. We're going to need to know those. Which identity might we want to use here? We have a squared here. What does that bring in mind? Without looking up your identities. Pythagorean. So, which one has a sine squared in it in the Pythagorean? Sine squared plus cosine squared equals 1. Can I manipulate that so I have sine squared minus 1? What would I have to do with that identity? All right, so let's try subtracting the cosine. And you said subtract the 1. Can we do it at the same time? Are you guys good with that? So that would be sine squared minus 1 equals what? All right. So that means my negative cosine squared is what I'm going to have right here. So that is equal to what? What do I have in the top? Negative what? Cosine squared over cosine. All right. Do I have just cosine happening now? Do you see any other trig functions there? Do you see a sine, tangent, cotangent, cosine, any other trig functions? I don't either. But they want cosine to appear only once. So how can we simplify that? Algebraic, right? What would I do? And what would happen? There we go. Because we have cosine, negative cosine times cosine over cosine, and what happens with one of the pair of cosines? And I'm left with just negative cosine. So one thing to keep in mind on this one, we don't have an end goal. They didn't give us the end goal. But they did give us some parameters for the end goal. Though they didn't give it, they did tell us, hey, we only want cosine there. Oh, and there shouldn't be any other trig functions, and cosine only needs to be once. So they're going to give you some guidelines and directions to get your end goal. But it is just our trig identities that we're going to be using on a problem like that. Okay. Any questions on AII? Okay, let's go ahead and look at B then. It's part B. Functions j and k are given. You see them there. It says solve j of x equal to 0 for values of x in the interval 0 to pi over 2. Hey, they gave us an interval. But it's not the whole unit circle because I'm not going to 2 pi. What part of the unit circle is this? First quadrant, right? Because I'm only going quadrant 1. I'm only going from 0 to pi over 2. So that's just our first quadrant. Let's go ahead and set up our equation. So we have j of x is 2 sine x cosine x minus cosine x equals 0. Any thoughts of how we could solve that, guys? We've seen a few of these. May have been a few weeks because it was last unit, but that's okay. We've still seen them. There's more than one trig, and there's more than one term. So factoring is probably involved. So how can we factor? What was that, Tiana? Cosine. Do we have cosine in both terms? Yeah, we do. and that's a GCF, so I can factor out cosine. If I factor out cosine, what do I have left? 2 what? Sine x minus 1 equals, and then what do I do with each of those factors? So both equal to 0, right? So I have cosine of x equal to 0, and 2 sine x minus 1 equal to 0, which means I'm going to have cosine x equal to 0, and if I solve that, sine x equal to 1/2. Now again, we want quadrant 1 values, so that's the only place we're looking, and we need to be able to do this without our unit circle. However, one thing is you're going to have some scratch paper when you do this stuff in the test. I'd recommend maybe doing a quick sketch of your unit circle so you can reference it throughout the test. Like just at the very beginning, just draw out the unit circle, bam, 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 bam. That's why I have you, needs to be less than 5 minutes. And then you can easily just reference it. So let's think, we already did it kind of up above, but what is our coordinate pair here at 0? 1, 0, okay. Up at pi over 2, what's our coordinate pair? 0, 1. What are our 3 angles that we have in quadrant 1? Pi over 6, what's next? And pi over 3. Do we remember which one is which? Now, let's think of pi over 6. Let's draw this triangle to help us remember. Which side of that triangle is bigger, the horizontal or the vertical? Is that horizontal bigger, right? So that means the x-coordinate is going to need to be larger than the y-coordinate. There are 2 possibilities here, rad 3 over 2 or 1/2. Which one is bigger? Rad 3 over 2 is bigger than 1. So then my x-coordinate would have to be rad 3 over 2. So then what does that mean my y-coordinate is? 1/2. Now if I go over to pi over 3, that triangle's kind of flipped. Which one's bigger now? The x or the y? The horizontal or vertical? Which one? Vertical, right? And that's our y, so that becomes my rad 3 over 2. And the other one's my 1/2. All right? And then pi over 4 is the same. So what is our values there, guys? Rad 2 over 2 for both. All right. In quadrant 1, without having our unit circle, we're able to quickly get a sketch there. We can now answer our question. Where is cosine equal to 0? Not at 0. Which one is cosine, the x's or the y's? And at 0, what is cosine at 0? So where is cosine 0? Pi over 2. So we have an answer up there. X equals pi over 2. Where is sine equal to 1/2? Not pi over, well, actually, yes, because I was incorrect. I was looking at the x's again. You're correct. Pi over 6 because the y-coordinate is 1/2. So we have our answer there as well. X equals pi over 6. They only wanted that quadrant, so there are answers. So you have to pay attention to your directions. Which quadrant do they want? All right. Any questions on that? All right, let's do part 2. K of x is equal to 3i. Solve for values of x. So let's go ahead and put our k of x in there. So that is 8 e to the 3x minus e equals 3e. How would I solve that, guys? Yeah, I wouldn't want to subtract. I'm going to add my e. What would that give me? So 8e to 3x equals 4e. What would I do next? Divide by what? 8. Let's do that. So I have e to the 3x equal, can I reduce that? 1/2, so I would have e over 2. Now, this is an exponential. I want to solve for x. I need to get rid of the exponential. What do I do to both sides to get rid of my exponential? What's the base here, guys? We use logarithms. Which log has base e? So we natural log both sides. And what happens over on the left? Because I have matching bases, because that is base e. And we're left with 3x. 3x equals this logarithm. Now, we might be inclined to divide by 3 at this point, but I would recommend you pause and think about this. I, again, have a natural log and an e. Do you think that might cancel out as well, eventually at some point? Yes, but I need to use my log properties first. I have division there. What would that change into? So 3x equals ln of e minus ln of 2. Now, ln of e, I can simplify. What would that simplify to? What's the power on the e if you don't see it? 1. What happens to the ln and the e? And I'm left with 1 minus ln of 2. Now go ahead and divide the 3, and you get an answer 1 minus ln of 2 over 3. But we have simplified because they've told us we need to simplify where possible. And it was possible there. So we do it. All right, any questions on part B? Part C. The function m is given by that equation. Find all input values in the domain that yield an output value of 9/2. Input values, aren't those x values, guys? Yeah. And output values, aren't those y values? Or in this case, specifically m of x values? So really, this is the same thing as those last ones where they said, hey, solve for m of x equal to 9/2. It's the same thing. I just set it up and I solve. So we have cosine of 2x plus 4 equal to 9/2, and I'm solving for x. What do I do first? Let's minus that 4. But I'm subtracting, so what do I need to have to be able to subtract? Yeah, so I have 9/2 minus, what does 4 become? 4 over 1, which would become 8/2. What's 9/2 minus 8/2? So we have cosine of 2x equal to 1/2. Now they want all places. So what are all the places on a unit circle where cosine is equal to 1/2? Now we wrote a little unit circle up here. Where is cosine equal to 1/2? Pi over what? And there's going to be another place on the unit circle, but that should help us. Where else would cosine, or the x, be equal to positive 1/2? It's in quadrant 4. What's the pi over 3 that's directly below that? There we go, 5 pi over 3. So I have pi over 3 and 5 pi over 3. Now, again, it's all. So we have 2x equal to pi over 3. But since it's all solutions, we need to add what? Plus 2 pi n e z. And then I have 2x equal to, we said, 5 pi over 3 plus 2 pi n e z. And then what's the last thing I need to do to finish that one? Divide everything by 2, except the n e z. We don't divide that by 2. So we have x equal to pi over what? What's pi over 3 divided by 2? pi over what? Well, remember that would be pi over 3 times the reciprocal 1/2. So is it pi over 6? Plus, and then what happens to the 2's there in the next part? And we're left with pi n e c. And then our other one, we have x equals what would be 5 pi over 3 divided by 2. 5 pi over what? 6. And again, the 2's cancel, plus pi n e c. They said that was supposed to be the hardest one. I didn't think it was that bad. But it's supposed to be the hardest one. And that concludes FRQ number 4. So FRQ number 4 is, again, just going to be very straightforward. You're going to be given functions, you're going to be asked to manipulate them or solve them. You will need to know your properties. You'll need to have those memorized. All right? Any questions? Okay, the 2 practice problems after that are yours to do for homework.